Welcome to this webinar, CFA Level 1 Economics. My name is Daniel Lambert. I'd like to support your learning, learning process during these different times, during this corona pandemic times, and support your Level 1 CFA learning with free webinars each and every Wednesday. I was dealing with fixed income 1 hour ago. I'll be dealing with economics now with elasticity in detail. And next week, it's about financial reporting and analysis and the other topics I forgot. So I'm trying to establish two subjects, two topics out of 10 every Wednesday. Out of those 10 topics, like alternative investments, ethics, ethical standards, quantitative methods, economics, financial reporting and analysis, fixed income, equity, portfolio management, corporate finance, and I forgot about the 10th topic that I'll be dealing with, but it's going to be 10. Now, equity. Equity right now. And once you're watching this video later after this webinar, feel free, if you like it, feel free to enroll in the next webinar, in the next one. So there's going to be a next exam, December 2020. And there's going to be CFA level 1 exams and these CFA level 2 exams, etc., etc., after these corona times. Now, economics. Economics, for example, deals with but of course not restricted to, but there is different subjects. But one of them, or three of them, are those elasticity, demand elasticity. It is reading 12. I think in 2020, in the 2020 curriculum, it's reading 12 of economics, and this reading is demand and supply analysis. And in detail, especially, it's demand elasticity, own price elasticity, income elasticity, and the cross price elasticity. So the first and the third can be summarized to being price elasticities, but the second is, or the third, I mean, here is the income elasticity. So the price elasticities, a certain price changes. Like with the own price elasticity, say the price of a certain good changes by, say, 1%, and let the elasticity be 3. This means that if the price goes up by 1%, so the quantity demanded goes down by 3%. Normally, it goes down. Normally, it's inversely related. So if the price goes up, the quantity demanded goes down, and if the price goes down, the quantity demanded goes up. Normally, this is the case. They are inversely related, but no, of course not always. Like with non-given goods, this is the ordinary case. With ordinary goods or with non-given goods, this is normally the case, an inverse relationship between the own price of a certain good, and the quantity demanded of this good. I'll shed some light later on with the demand function, but let me just point out this first of all. And if you want to watch it, please note that we are in minute 4. This is the fourth minute of this video, of this webinar. So feel free to just pause or to go to minute 4 and watch this video, because I just interpreted the own price elasticity of, say, 3, for example. And if it's negative 3, then we have the inverse relationship, and if it's positive 3, we have a relationship with given goods. That means, like, if the price goes up, so does the quantity demanded, and if the price goes down, so does the quantity demanded, which is not ordinary, which is not normal. It's innormal, it's anormal, like it's not ordinary at all. The percentage change in price demanded divided by the percentage change in price equals the own price elasticity. Now, with the cross price elasticity, it's also a price elasticity. If we're looking at two different goods, if we're looking at two different goods, and the price of the first good goes up by 1%, and we're looking at the cross price elasticity of say 4, this means that say plus 4, then the quantity demanded of the first good goes down, and the quantity demanded of the second good of a different good goes up by say 4%, right? So this would be, or these two goods would be called substitutes in this case. Substitutes, if the price of one good goes up and so does the quantity demanded of a different good, then they are called substitutes. So positively related, if they change in the same direction, it's about substitutes, which could be true this way or that way. And if it's the other way around, if then we would be talking about complements. Complements, right? So this is it, talking about cross price elasticity. And the income elasticity is not dependent on the price, it's dependent on the income. So if the income varies by 1% up or down, and so the quantity demanded of a certain good goes up or down. It goes up with normal goods, so the income and the quantity demanded, if they behave in to the same direction, then it's normal goods. And if they behave in different direction, like rising income and decreasing decreasing quantity demanded, then it's an inferior good. Or same holds true with this. If the income goes down and the quantity demanded goes up, then it's an inferior good just as well. So income elasticity and own price elasticity are about one single good dependent on the own price or on the income, whereas the cross price elasticity is the quantity demanded of a good dependent on the price of a different good. That's uh, I was just trying to include this mind map. Now, let's shed some light on certain elasticities. For example, let the demand function be this. There's a price and there's a quantity demanded. Let a capital P denote the price. Sometimes it's denoted by lowercase p. In most cases, it's denoted by uppercase p. In most cases, here with CFA Institute, that tells us that the price of a certain good is denoted by uppercase p. The thing is, like in most books, I would say, in most universities around the world, we denote a single price with lowercase p, whereas uppercase p denotes the price level in macroeconomics. But no matter. I mean, I don't want we want don't want to argue about this. So capital P, uppercase P denotes a single price only, and this is microeconomics. This is not macroeconomics. This is not the price level. Let the demand function be. What do you think about this? The price equals 8 minus 2 times Q. How about this? Do you like this demand function? I think so. If the quantity demanded is 0, the price, this price, is equal to 8, isn't it? If the quantity demanded is equal to 2, then we have 8 minus 2 times 2 equal to 8 minus 4 equal to 4. So with the quantity demanded of 2, the price is 4. And that's important because I was talking about something that's weird because it's not true. The relationship is the other way around. The price influences, the price impacts the quantity, not the other way around, right? The quantity does not impact the price, but the price impacts the quantity. This is why it's an inverse demand function. The thing I just wrote down, P equal to 8 minus 2 times Q, is not the demand function, it's the inverse demand function because the relationship is wrong. there is no relationship. I mean, not in such a way that the quantity influences and impacts the price, but actually it's just the other way around. So we would have to solve for the quantity, meaning p minus 8 divided by negative 2 equal to q equal to, in turn, 4 minus 0.5 multiplied with the price. So this actually would be the demand function painted in yellow, if I may paint it for you, whereas the other function, this one, the green function, is just because it's somehow subordinated. It's not the same thing. It's the better thing. The yellow function is the better function because it tells us the relationship, which variable impacts which one. The price impacts the quantity, but not the other way around. So the green one is the inverse demand function, whereas the non-inverse, the actual, the real, the true inverse, the true demand function is denoted by the yellow only by the yellow function. So if the quantity is equal to 4, we have a price of 0. And so those are 3 points. If we put them together, we see that it would have sufficed to actually paint 2 points because it's a straight line. It's a straight line, it's not a curve, it's a straight line, and there are only 2 points that would totally suffice in order to paint such a straight, in order to really depict such a straight line. So 2 points would have sufficed totally. Um, if this good, I don't know what it is, banana or books or anything, if this good would have been given for free to the public, to the people, then the people, consumers, would have asked for 4 units only. So it's 4 units only because if they're given this good for free, so if the price is equal to 0, the quantity demanded isn't more than 4, it's only 4. And so the point of saturation, as to call it this way, because people are tired of consuming more than 4 units of this single good. Now this is the demand function. Talking about elasticity, what is the own price elasticity of this good? And the elasticity given by or denoted by epsilon, for example, this Greek letter epsilon. If we compute the derivative of the price, so we we derive the quantity function, the yellow function, we derive the yellow function, or we compute the derivative of the yellow function um, with respect to the price, then it's and this ratio, this derivative is multiplied by the ratio of the price divided by the quantity. So the numerator is given by the price and the denominator is given by the quantity. And it's important to and I want to paint it the yellow way again. It's important to substitute this function. Like, first of all, the derivative, of course, given the yellow function, in order to derive to p, it's negative zero point 0.5 multiplied by p divided by 4 minus zero point 0.5 times p. So this is actually the the elasticity. This is the elasticity given any price. So if you tell me now, Daniel, um, what's the elasticity given a price of 2? Or what's the elasticity given a price of 5 or 6 or of 8? Not of 9, because this doesn't make any sense at all. Um, it's possible, of course, but it doesn't make any sense. But between a range in a range of 0 to 8, you could ask for the elasticity. If we ask for the elasticity given a price of, say, 2, what is the elasticity? The answer is this: negative 1 over 2, 0.5, or of course this ratio, 1 divided by 2, multiplied by 2 divided by 4 minus 1 over 2 multiplied by 2. This will tell us 1 over 2 multiplied by 2 divided by 3, because 3 is the quantity demanded, isn't it? If the price is equal to 2. So we derive that epsilon, the elasticity, the price elasticity, the own price elasticity is now equal to 1 over 3 is now equal to 0.3 recurring, 333, 333 to infinity, isn't it? So if we take the absolute value, then it's, so the absolute value of elasticity is zero point 0.3 recurring, 333, 333, and so on, and so on. So if I round it to two decimal places, it's 0.33. But we know that actually it's 333, 333 to all infinity. Given a price of, say, 4, then it's a different story. It's 1 over 2, negative 1 over 2, multiplied by 4, divided by 4 minus zero point 0.2, multiplied by 4, which should be, to my understanding of computation, 4 divided by 4 minus 2, so equal to 2, because the quantity demanded here in this case is equal to 2. Didn't I paint it in a good way? What a nice painting. What a nice painting. So, um, so actually, 4 divided by 2 is, so this is negative 1, or if you take with the absolute value, then it's positive 1. So we know from deep inside that the elasticity is negative. Here in this case, it is always negative, but we're only interested in the absolute value, and this is positive 1. One last thing to compute, or maybe two things to compute, with a price of 6, it is, if the price is 6, then it's 1 over 2 multiplied by 6 divided by the quantity, and it should be equal to 1, but 4 minus 0.5 multiplied by 6 should be equal to 6 divided by 4 minus 3, isn't it? Which is 1. So we have minus 3. And yes, it is, it is 1. Mhm. So this is the point we're looking at here. Um, so the absolute value of the elasticity is equal to 3, which tells us with the price of 8, if we insert the price of 8, it's a bit nasty because we would divide by 0. And have you ever divided by 0? Don't you do it? Don't you do this? So actually, because we divide by 0, the actual elasticity is positive infinity, or the absolute value. And here, the elasticity is 0. Absolute value or not the absolute value, whatever, it is 0. So we have we just computed 5 different elasticities. So first, try to understand it again. If the price is 2, and if the price rises by 1%, from 2 to 2.02, then the price change the price change is 0.333%, isn't it? From 3 to what is, do I have my handheld computer here? I don't think so, but you have it, and so you can compute it. So the quantity demanded goes down to and goes. What did I say? Did the price go up? I think so. If the price goes up by 1%, so the quantity demanded goes down by 0.333%. That's it. And the same holds true with different values, of course, with different points. So there are actually two areas. There were two areas. First, this area, so turquoise, and this area, the pink area. With the pink area, the price elasticity, the absolute value of the price elasticity is strictly superior to 1. This is called an elastic area. So this is the elastic area, the, the region shaded in pink, because the quantity demanded behaves stronger than the price behaved. First of all, the price moves to a certain direction, be it up or down, no matter. And the quantity demanded reacts. So the price changes and the quantity demanded reacts as a consequence. And it reacts stronger than the price behaved, than the price changed. Like, for example, if the price is equal to 6 and it changes by 1%, then the quantity demanded reacts by 3%, which is stronger than 1%. So that's why we call it an elastic reaction. Now, with the area in turquoise, I don't know how to pronounce this word, so maybe blue, but to be more precise, it's turquoise, isn't it? The inelastic area, because if the price changes by 1%, the quantity demanded behaves and reacts weaker than 1%, not as much as the price reacted. So, in order to put it this way, the price action is stronger than the quantity demanded reaction. So, the reaction is weaker than the price action, first of all, has been before. Um, that's it. That's it. Talked about the elasticity of demand and the own which is the own price elasticity of demand and the two possible reactions. There is of course a stronger demand function. How about this? If the demand function is given by this one, what would you say? What would you say if the price goes up? Does the quantity demanded behave in any way at all? No, it does not. Because if the price goes up and the quantity demanded does not go down, we are talking about a totally inelastic demand. This demand and this demand function, is this a D? I would say so. This shall denote the Latin D. The demand function is totally inelastic, so everywhere it is inelastic, totally inelastic. And whereas here, with this demand function, it was inelastic only at the point given by 4 and 0. So a quantity of 4 and a price of 0. So here, at this point, this was the inelastic one, but that was one and only one point. But here, every single point is denotes an elasticity of 0. So here we have a totally inelastic demand function. Say, for example, um, you are diabetic, you are type 1 diabetic, and you are totally dependent on insulin. So you need insulin, and the price of insulin goes up by 1% or by 10 or 20%. I mean, what could you possibly do? Nothing. Could you reduce your quantity demanded as you would normally do with bread or butter or something or anything? No, you can't. So if you are dependent, if you are addicted to something, or if you are totally dependent on something because of health reasons, then you would demand any number, any you'd be able. No, you wouldn't be able, but you'd be willing to pay any price. You would be willing to pay any price because you actually need this good. I wouldn't call it a good any longer. I would really rather call it an evil, but that's a different story. We have to call it a good because that's the way it's called. So, for persons being addicted or being, for health reasons, being totally dependent on a certain good, it's about true to call it a totally inelastic demand function. That's it. That's it for now. I'd say it was nice to have this webinar. Next week, it's April 15th today. Next week on April 22nd, it's financial reporting and analysis. And I forgot to the second webinar. But anyway, it's my Facebook profile, Lambert Education. Next week, in financial reporting and analysis, we'll be dealing with recognition of assets and with measurement of assets. So, talking about understanding balance sheets, it's first of all, it's important to answer this question: shall an asset be recognized? Shall an asset be recognized on the balance sheet? And second, if the answer is yes, so if it is capitalized, if the expenditure is capitalized, then second question is to measure it and how to measure it. There is initial measurement being cost, and there is subsequent measurement in the next years, and that is if it's a depreciable good, there is depreciation and amortization. Like with intangible assets, it's called amortization. With tangible assets, it's depreciation. And so allocate the cost, we allocate the expenditure of the first period to the useful life of the asset. And there is not only depreciation and amortization, but there is a possible impairment. Maybe there is an impairment. And all of this shall be looked on next week. So if you like this video, please tell others. If you didn't like this video and if you didn't like this webinar, please only tell me. I'd say see you next week. Thank you for watching. Stay tuned until next week. Thank you.